Lesson 2-8 is on graphing linear and absolute value inequalities. And I think we did a little bit of this in Algebra 1, so this should be a little bit of a review. A linear inequality is similar to a linear equation, but instead of an equal sign, it has a less than or equal to, a greater than or equal to, or a greater than sign. Its graph is a solid line if it's a less than or equal to, or a greater than or equal to, or a dashed line if it's a less than or a greater than, and then one side of that line is going to be shaded. You're either going to shade above the line or below the line. Let's take a look at a couple examples here. So let's graph 3x plus 1/2 y is less than 2. In order to graph this, I'm first going to put it into what looks like slope-intercept form, y equals mx plus b. So I will subtract 3x from both sides. And then multiply both sides by 2. And that gives me the inequality y is less than negative 6x plus 4. So looking at this, since it's a less than and not a less than or equal to, it's going to be a dashed line. And as long as it's written in y equals mx plus b form, if it's a less than, I'm going to shade below the line. It will be shaded below. So let's go ahead and graph this. So my y-intercept is 4, and I want to go down 6 and right 1, or up 6 and left 1. And it needs to be a dashed line, so let's fill in with some dashes here. Doesn't have to be perfect, just needs to be obvious that it's dashed. And for my shading is going to be where the y-axis is below this line. So this line is pretty close to vertical, so it's going to be a little hard to see, but where it's actually below is down here, where the y-axis is underneath the line. So everything on this side of the line is going to be shaded. So what does this mean? This means that every point in that shaded region works in this inequality. So if I were to pick any point over here and I plug in the x-coordinate for x and the y-coordinate for y, this inequality would be true. Y would be less than negative 6x plus 4. Take a look at what an absolute value inequality is going to look like. It's going to look like an absolute value graph, so it's going to look like a V, and it's going to be solid or dashed, and then we're either going to shade inside the V or outside of the V. So let's take a look at this one. So I have 2y is less than the absolute value of x plus 3. So I need to get y all by itself, so I'm going to divide both sides by 2, so that gives me y is less than 1/2 the absolute value of x plus 3. Now, if you really don't want to make a chart, we could do this in the calculator. Let's see what it looks like in the calculator. So let's do y equals, I'm going to use 0.5 for 1/2. Remember, absolute value is in the math menu. We'll go over to number, and I will take absolute value. And I need x plus 3, and let's hit graph. Okay, it looks like the vertex of my graph is at negative 3, so I'm going to copy my table from this. So if I look at, actually let's go to table. And let's pick some values that are, so if I do negative 3, I get my 0, but I want something that's going to be to the left of it and something to the right. So what if I start with, let's start with negative 5. Okay, how about negative 4? Oh, that's giving me a fraction. And negative 3. So it looks like, and I think that's because of I have the 1/2 out front. So look, negative 3 gives me a 0. Negative 5 gives me a 1. Why don't I try a negative 7? I think if I skip like that, if I do negative 7, I get a 2. If I do negative 5, I get 1. Negative 3, negative 1, and 1. I like the looks of that table. So let's go ahead and copy that. So that was negative 7 gave me a 2, negative 5 gave me a 1, negative 3 gave me 0, negative 1 gave me 1, and a positive 1 gave me a 2. So let's go ahead and graph those points. 2, 4, 6, 7, 2, 5, negative 1, negative 3, and there we go. Oh, and I forgot to notice, what do I have to do here? So I need, since this is a less than, not less than or equal to, this is going to be dashed. And since it's a less than, I'll be shading below where the graph is. Where is the y-axis below the graph? So let's go back and put in some dashes. I'll just kind of extend it out like that. Okay. Now, where is the y-axis below? In this case, it's actually outside of the V. So what I want to shade is all of this down here. That's not real neat, but you can do a neater job in your homework. Okay, and remember what this means is that any point in this shaded region works in this inequality. So if I were to pick any point down here and plug in the x coordinate for x and the y coordinate for y, this would be a true inequality.